Hello YouTube, so today we're going to be doing a video about this circuit right here. So this circuit, it functions as a 7-segment decoder, but it uses an Arduino. If you're familiar with the 7-segment decoder, you could make it using just a combinational logic circuit. What it does is it takes a binary number or a binary coded decimal number if it's bigger, and it will take that and convert it into a decimal or hexadecimal number on your screen right here that you could read. So it's one of the more basic forms of display. If you want to see a binary number without having to just have LEDs for each bit, which gets a little annoying, especially if you don't know binary numbers. Even if you do, it's still annoying. But you would make something like this. And it's using an Arduino, which is normally you would use a combinational circuit or an FPGA or something like that. I guess using an Arduino is fine, though it does take up pretty much all the pins. Though it does have enough pins, which is good. So what it does is the binary numbers here and the displays out there. So let's demonstrate it. So this is the least significant bit. This is the most significant bit. Going from least to greatest, it's 1, 2, 4, and 8. So if I could just demonstrate it like this, it's 1 and 2 and 4 and as well as 8, which is 8. Yes, so you saw that it displays the number correctly on all these. Also, we could count up from 0 to 15, which is the hexadecimal limit. As I said before, it's a hexadecimal or decimal number, depending on what you send here, just because binary coded decimal requires 4 bits, and 4 bits is going to give you 16 values, whereas for decimal you only need 10, but you can't use just 3 because that's not enough. So whether it's decimal or hexadecimal numbers depends on whether you're using a double circuit, which that would convert a larger bit number into binary coded decimal using 4 bits, and then you'd have to have multiple of these circuits, and that would go to another 7-segment display like this one, which would just be beside that, so you could have 2 place values. But we don't have any of that here, and that's going off on a tangent, so let's get back to this. So let's count up from 1, it's 1, 2, 3, and then we put those back, and then for 4, 5, 6, 7, we put all of these back as we go up to 8, which is this one, 8, and 9. So these are your decimal numbers. And if you want to go to 10, it's going to go to hexadecimal, and that's going to be A. So 10, 11, which is B, B, and then 12 is going to be C, it's C. Another thing is, if you want, you could have CB use this middle bar instead of these two. It's important to you. C, and that's going to be D, and then we're going to do that, and then it's going to be E, which is 14, and 15 is going to be F. So there you go. That's how it works. Instead of just switching it like this, which is kind of dumb, you would have this connected to a circuit which made a binary number output, and then you would have your nice readable number here. And that's how that would work. So let's go over like the physical circuit of this. It's pretty simple, as everything's done in software pretty much. You just have the connections for these resistors so the LED doesn't burn out. And then you have have some pull down resistors here. These are your inputs, these are your outputs. The Arduino has pretty much all of its digital pins used except for D13 and the analog pins, which I guess you could use the analog pins too, but that'll be kind of inefficient as well. So we have that. So as I said, everything's done in software, so we have to look at what's actually going on. So these are the Boolean equations or whatever they are that will make the 7-segment display work. So all of these are digital values. They're either on or off, so it's high or low, and then we use the operations such as and, not, or, nor, all those. And doing combination of them like this and this, we could have it so when the inputs are what they're supposed to be, the correct LEDs light up, and that makes the number that we see. So also ignore the black ones. Those are, some of them are not correct, but the blue ones and the green ones are correct. So just going over this, we are using the digital pins D9, D10, D11, D12, and these digital pins as well. You could see them, but you could use whichever ones you want. So as I said, for A, which is on D3, it's this one right here. It's not Z, not Y, or W, or X and Y, or Y and W, or all of this, or Z and not Y and W, or nor X, Y, or Y and not W. So it's pretty complicated to just look at. If you want to see them right here, here you go. Pause the video. If you want to make this yourself. As I said, look at the green ones or the blue ones. In my opinion, the green ones are much easier to read, but the blue ones are what you actually have to type if you want to program an Arduino like this. So let's look at the code that's actually on the Arduino. I could do screen capture, but this is just easier to post the video faster. So let's scroll up and see what's going on. It's pretty simple, actually, if I can get it correct. And then we could have something to go to, yes. Yeah, so it's kind of long just because you have so many variables, but these are all Boolean variables. X, Y, Z, W, these are your inputs. A, B, C, D, E, F, G, these are your outputs to drive the display. And then these are constant integers. These are just to define the pins and which pin number they are. That's how the Arduino functions work, where you have to define the pins as integers. And then here we go. We are setting the input pins, the output pins, just standard Arduino stuff. And here's what it's actually doing. It's reading the input pins, and then it's applying the equations which I explained. And depending on how these are, how the inputs are in these ways, if all of this is true, then A will be high, and then the LED corresponding to A will light up. The same goes for all of these. It's very complicated to read. And then we are going to output the value for A, which I said the A, B, C, D. These are all Boolean variables. And then we are going to output that to the pin, which means if this is true, then the pin will be on. If this is true, voltage will be applied to these pins. It's not that complicated of code, but it was kind of laborious to write all this out. So yeah, that's how you make a 7-segment decoder using an Arduino, which is kind of a strange project to do. If you were going to do this, I don't really know what kind of application you would have it be using. Maybe if you're making a binary circuit, like a simple computer or something using just logic gates, and you want to quickly know which number they are, you could use this or something. But if you're actually using this for an application using the Arduino, this might not be the best thing to do just because it uses so many pins. So what you could do is you could use a shift register, which will basically store variables, whether it's on or off, for each pin, and then you could just cycle through that really fast. And then you could only use a couple pins to drive this display. You could drive multiple displays, and then you could have the Arduino has other pins for you to do other stuff rather than just this. But this was just for demonstration. As I said before, copy the equations in green if you want to do this yourself. Hopefully I'm making this visible enough, but yeah, that's just how to make a 7-segment decoder using Arduino. See you in the next video.